This lesson is looking at all the things that we can compare between two lines given their slope for the most part, and also maybe the y-intercept, a couple other things. For example, your first vocabulary word might give you some hint as to what we're looking at. I know you know what parallel lines are. For our purposes in this class, we are looking at two lines that have the same slope, and as always, parallel lines, two lines that are always the same distance apart and never meet. Next vocabulary word you need is opposite reciprocals. There are two steps to finding an opposite reciprocal. First, take the reciprocal of a number. Second, change the sign. For example, 3/4 and -4/3 are opposite reciprocals. You need to know opposite reciprocals for when we look at perpendicular lines. Perpendicular lines are two lines with the opposite reciprocal slope. For example, one line with the slope 3/4 and another line with the slope -4/3 are perpendicular to each other. Page 327, this helpful little box here, they are showing you non-vertical lines are parallel if they have the same slope and different y-intercepts. Vertical lines are parallel if they have different x-intercepts. And then they give you the graphs of these two lines here. Check it out. Each of them has the slope 1/2. So we know that two lines are parallel if they have the same slope. We know that we have this line here with the equation y equals 2/3 x minus 1. We know that the slope of that line is 2/3. We have a point on a second line, and we know that it's parallel. So, can we use what we know to write the equation of the parallel line that goes through this point? Sure. They want it ultimately in slope-intercept form, but right now we have one point on this line and the slope of this line. So we're going to start with point-slope form and simplify. Point-slope form, plug in what you know, slope, y-coordinate, x-coordinate, distribute, simplify, and there it is in slope-intercept form. So y equals 2/3 x minus 3 passes through that point they gave us and is parallel to y equals 2/3 x minus 1. Try it yourself for got it number 1. And just a reminder, I expect that in addition to vocabulary, you're going to have these got it problems in your math notebook. There's a box close to the bottom, these slopes of perpendicular lines. They go over this a little more closely. You can see two lines graphed here. They look like they might be perpendicular, and then they also give you the equations for those lines. You see that the red line has a slope of 1/2. The blue line has a slope of -2. I'm kind of hoping that you don't have to do this in order to tell me that 1/2 and -2 are opposite reciprocals. You should kind of. So with problem 2, they're giving you two equations, and they want you to figure out, are those two lines parallel, perpendicular, or neither? Well, first thing you need is the slope of each of those lines. This one's easy because it's in slope-intercept form. This one, not so much. You either have to remember the quick way to figure this out from standard form, or you're going to have to manipulate that equation and put it into slope-intercept form. you end up with the slope of this line is negative 5/4. The slope of that line is 4/5. Oh look! Opposite reciprocals. So they must be perpendicular. And again, this whole step 2, you really shouldn't have to do this. Got it. Number 2, letter A, letter B. Get them done in your book. So I'm going to talk you through letter A, and then I'll just show you letter B. The slope of the first line, it's easy. It's in it's in slope-intercept form, so it's 3/4. The slope of the second line, oh, here's the tricky way to do it. It's in standard form, but you know that standard form means the opposite of A over B is going to give you your slope. So there's the slope of the second line. Those two lines are neither parallel nor perpendicular. Why? Because 3/4 and 4/3 are reciprocals, but not opposite reciprocals. So they're just nothing. Okay, this shouldn't be too difficult. Writing an equation of a perpendicular line. They give you the graph of one line, where notice what I'm pointing at here. They give you a point on this perpendicular line that they want you to create, and you need to come up with an equation for it. Too bad I'm not going to let you use the multiple guess answers. So, as you know, the slope is 1/3. The opposite reciprocal of 1/3, -3. So now we have a point and we have the slope. So use point-slope form, substitute in what you know, distribute, turn it into slope-intercept form, because that's what they asked for in the original question, and you're done. Try got it number 3. It's exactly the same thing. You've got the slope of the perpendicular line, you've got one point, create the equation of the new line in slope-intercept form. So problem 4. Sometimes these real-world problems I find are very helpful because they use a situation that you might actually run into in your life. Sometimes I find they're very contrived, meaning they had to work really hard to come up with a math problem, and this is one of those kinds. You've got a ceiling, there's a beam going this way. Don't ask me why you have a beam going on the diagonal, not across the middle of a ceiling. I don't know. They are showing you here how to figure out the equation of a perpendicular beam. Again, don't ask me why you want a perpendicular beam. Anyway. So you know how to do this. You have the 2 points. Slope of that beam. Then find the opposite reciprocal of the slope. All right, next, point-slope form. Create your equation. Simplify it to slope-intercept form. Now that we've gone through all of that, got it number 4. This architect, who I think probably needs to go back to school, wants to put a second beam that's going to go, oh look, through the corner. Well, that makes a little more sense. The second beam is going to go through the corner and be parallel to the existing beam. Still not making any sense to me. But regardless, you have the slope of the new line. Why? Because it's parallel to this red line. You have 1 point on this new line. Give me an answer in slope-intercept form. What's the equation for the crazy new beam? Boy, you can tell when I don't like a problem because I really don't feel like I explain them very well. At any rate, as long as you can look at an equation of a line, find the slope, figure out how to create an equation for a line that is parallel or perpendicular to the given line, you're all set. Here's your classwork. I'm doing something just a little bit different this time. I want everybody to do 8 through 26 even. But if you get to problem 26 and you still have a fair amount of class time left, I want you to also take a look at number 36. Good job. All done.